Locating and quantifying necking in piles through numerical simulation of pile integrity test by Professor Tariq Salim, Professor Atif Iraqi, Engineer Abdullah Al-Misallami. Introduction. Defects of concrete piles can occur at any point during the construction of piles. This research introduces several numerical models of defected piles, various scenarios to identify, locate, and quantify the necking in piles. The finite element software ADINA is used to simulate the studied models. The soil domain is modeled as an axisymmetric space around the concrete pile. 5 diameter of piles 40, 60, 80, 100 and 100 centimeters are studied. Necking is modeled at upper, middle and bottom third along the pile. 4 ratios between the necking diameter and pile diameter are also studied. The shown table introduces the characteristics of the soil and the concrete, and the force-time relation shown defines the impact force used. The 3D section is for the soil and the pile finite element meshing, and the 2D section is clarifying the boundary constraints. The shown velocity response is for an intact pile of 100 cm diameter. The symbol T sub LP expresses the time indicating the distance between the pile head and its end. Parabola A is the pulse induction and named as the initial parabola. Parabola Z is the terminal parabola or the end parabola. The introduced comparison is for velocity response for an intact pile 100 cm diameter versus for defected piles at upper third of the pile length. The research schematic diagram has a new conclusion that it may introduce approximately the volume of the defect and its location.